we've been talking about right triangles and their special relationships among them. We can always use the Pythagorean theorem, but sometimes it's much easier to know these relationships and the computation can be simpler. So let's look at what they are. If we have an isosceles right triangle, that means two sides are the same length. There's a special relationship that says one leg, the ratio to one leg to another is x, and x roots of 2. And this is important to draw on the triangles when you're trying to solve. We'll get to examples in a minute. A 30, 60, 90 has x roots of 3, and 2x. Let me show you how we came up with these numbers. So on this triangle, according to Pythagoras, we could say, this is for the 45, 45, 90, and when I'm done, I'd like you to write this down. Might help you remember what the ratios are. I have x squared plus x squared because these two sides are the same. And the sides opposite these angles are the same length. And that's going to equal something else, c squared. So if I add these together, I have 2 of them. And I want to know what this length is of the hypotenuse. I'm going to take the square root of both sides. So I get x roots of 2 equals the hypotenuse. So that's how we get this number, x roots of 2. Let's do the proof for 30, 60, 90. For that, I'm going to draw an equilateral triangle. So let's use one. And I want to do a line from the vertex perpendicular to the base, and this will bisect. Okay, come back here, triangle. Means this angle and this angle are congruent. And since this is equilateral, we know all the angles are 60 degrees. We know the sides are all congruent. And a line that bisects the angle of an isosceles or equilateral triangle also bisects the opposite side. So for starters, since it's bisecting the angle, the measure of each of these angles is 30 degrees. 60, and this is our right triangle. And if I want to call this length x from here to here, then this would be double it. All right, that's just our common sense here. So let's put this in the Pythagorean theorem, and this is the one I don't know. So I have x squared plus the one I don't know, I'll call it b squared, equals 2x squared. And I'm going to subtract x squared from both sides. So I get b squared equals 4x squared minus x squared. So this is 3x squared. And now if I take the square root of both sides, I get the side I'm trying to find out is x roots of 3. And it's always the side opposite the 60-degree angle. So that's how we come up with these ratios. And your job now is to remember 1, 2, 3. And for the 45, 45, 90, we only get to 2 because two sides are the same. But on the 30, 60, 90, we get 1, 2, 3. Now the thing to remember is the hypotenuse is always the biggest side. And 2x is greater than x times radical 3. How do I know? Well, if I change 2 to a radical, this would be the same as, and this x times the square root of 4 is going to be bigger than x times the square root of 3. Because the square root of 4 is bigger than the square root of 3. Okay. Examples, how we're going to use these. First job, when you have an example, you need to stop and write down the ratios. If they have an x for a variable, don't use x. They don't have an x, so I'm going to write this side as x, this is x, and this is x times the square root of 2. So now I can just substitute, because x equals 5 roots of 3, so I have 5 roots of, 6, to substitute in for the x times the square root of 2. So this is 5 times the square root of 12, which is 10 roots of 3, because 12 is 4 times 3. I can take the 2 out, leaving the 3 under the radical. 2 times 5 is 10. All right, well, now the class is going to be doing these, but I'll quickly do these for you since you are viewing this not from the classroom. 22 equals x roots of 2. Both of these sides are x, so let's see. If x roots of 2 equals 22, I'm going to divide both sides by the square root of 2, and I get x equals 22 over the square root of 2. I can't have square root of 2 in the denominator, so I multiply top and bottom, not both sides. This is the equivalent of multiplying by 1. So I get square root of 2 times square root of 2 is 2. 22 roots of 2. I'm almost done. 2 goes into 22 11 times. So my answer is 11 roots of 2. And unless the problem says to write it as a decimal, always leave it as a simplified radical. We have a square playground. So if it's square, we know this is a right angle, so this is the hypotenuse. So this must equal s roots of 2. So let's solve that. S times the square root of 2 equals 96. S equals 96 divided by the square root of 2. S must equal, okay, so I get 2 into 96 is 48 roots of 2. Here's a 30, 60, 90 triangle. Opposite the 30 is x. Opposite 60 is x roots of 3. Opposite the right angle is 2x. So first I write my ratios, and then I try to solve for x. So here I'm given 18, and that equals x roots of 3, and we do our algebra. And we clear the denominator, we rationalize the denominator. And so I end up with 18 roots of 3 over 3 equals x. So 6 roots of 3 equals x. And so now I can say d equals 6 roots of 3. F equals 2 times this, so it's going to equal 12 roots of 3. I need both of these written down. Right, let me show you about a rhombus. There are, go back to this other page, and then we'll be done. There are 2 ways to find area of a rhombus, and it depends upon what information you are given. So if we're given something about the diagonals, you can, well, there's 3 ways. You can find the area of one triangle and multiply it by 4. Or you realize that a rhombus is a parallelogram and it's just base times height. So if you get a figure something like this, you're going to find the area by doing base times height. And this is your height and this is your base. If you get some information about the diagonals, we remember they bisect each other. And so the formula when given diagonals is diagonal 1 times diagonal 2 divided in half. The way we get this is here's our base and here's our height. So the triangle area is 1/2 base times height. This base is 1/2 of this whole diagonal. So I have diagonal 1 over 2, and this height is 1/2 of the other diagonal. Now this is not an addition problem, so we are going to multiply. So what I have right this minute for one triangle is I have 1/2 diagonal 1 times diagonal 2 over 4. That's just one triangle using diagonal measurements. But I have 4 of those. So I can cancel 2 into 4 goes 2. And 2 over 4 goes 1/2. So I get diagonal 1 times diagonal 2 divided in half for the area of a rhombus. 2 different formulas. This one when we're given diagonals, and this one when we're given height and base. So I think that will help you